Hello and welcome to my next video. We're going to talk about consumer preference theory is a fancy way of saying it in this video, perhaps more than one because there's quite a bit to pack through here. But before we get into that, by the way, from now on I'll just call it utility. And I'll explain the definition of utility later. But before we do that, we get into utility, I want to sidetrack just a little because if you will really understand what I'm about to show you, it will help you understand a lot of the concepts we're going to be studying from here on out, where we think about values that have totals, averages, and marginals. So let's dive into that. Let's go through a great example because I think most of you can identify with that. So let's suppose that we've got a class with 6 grades, and we want to see what the total points are. We want to know what the average points are, and we want to know what the marginal points are. And it'll become clear, especially marginal may not be something you're super familiar with yet. So test number 0, obviously you haven't had any tests. You can't have any points. Obviously, you didn't make a grade because there's no test given. And then test number 1, unfortunately, it looks like maybe this student made a 60. Well, we go from 0 points to 60 points, so the total points are now 60. We've had 1 grade, so 60 divided by 1, that's how you calculate the average, is 60. And now marginal. Marginal is a 1 unit change, an incremental change. So going from 0 test to 1, incrementally, our score has gone up by 60 points. So that's the marginal in this case. It's kind of an in-between. That's why I've shown it this way. Now, the second test, we do better, or this student does better, makes a 70. Well, 70 and 60 would give us 130. That's the total points from the 2 tests. But now we have 130 points and we've had 2 tests, so we divide that by 2, and that gives us an average of 65. But notice the marginal value is the change from the previous total of 60 to the next one. Well, that's nothing more than just the last test. So the marginal is 70 here. And we go through this pattern. So the third test, unfortunately, is a 50. That adds 50 points to the total to give us 180. We divide 180 by 3 to get the average, and then the marginal in this case is just that last test score of 50, and so on and so forth. So let's take this data, and first we'll look at the total graph. So after the first test, we've got this endpoint here, second test, third test, fourth test, fifth test, sixth test. And again, we can go back. So we're talking about this column here as the y-axis, if you will, or the vertical axis values. And here, this is would be the x-axis or the horizontal axis values. So notice that the total is always increasing. Now it's not a straight line because our test scores are not exactly the same each time, but notice it's always increasing unless we had a negative value for one of those tests. Now I want to take the same information, so once again let me go back here, and I'm going to plot horizontal axis test number, and then on the vertical axis we're going to plot marginal and average and marginal. So here we go. This one curve that's higher up right here follows the marginal values, and this lower curve, if you will, follows the average value. Now here's the important thing out of this. Again, I apologize, and I'm going to re-emphasize. So notice the total is always increasing any time that there's a positive number of points. Even if you scored a 1, total would increase by that 1. But notice that marginal and average are not always increasing. Marginal is first, and I want to compare these two. Marginal past really, it's only relevant if we talk about the after the first test. This part's irrelevant just because of the numbers. But up here, notice if marginal is above the average, what's happening to the average? It's pulling the average up. In other words, if your last test score was above what your average test scores were previously, it's going to pull up that overall average test score. On the other hand, if the marginal is below the average, it's going to pull the average down. So notice the relationship between marginal and average. Furthermore, notice something else going to be very important for you. At the point of intersection where marginal equals average, that average value is going to either be at a local maximum, in other words, the highest point in that area, or the lowest point. So where marginal equals average, that's going to give us either an area in this region, in this area where it being average is at a maximum point or at a minimum point. If you will really understand those concepts, then it will be very useful for you for the rest of the semester. So you might want to go and review this slide later on if necessary, or look in my text notes. Now let's go back to consumer preference theory, utility. Utility, the way we use it in economics, is just jargon for satisfaction. And we measure it in mythical units called utils. Now those mythical units, we're getting close to actually being able to measure those in the real world with the way we can measure brain waves and those kind of things now. But let's just stay with kind of the classical idea of utils being some kind of mythical unit that we come up with. Now, we assume in microeconomics that the goal for the consumer is to maximize total utility. Notice that we're still kind of looking on the demand side of market, supply and demand. And so I'm going to switch gears here and suppose that we're looking at purchasing, and actually it's before the fact. You have to calculate your expected satisfaction before you actually buy something, because you're going to calculate, well, is it worth what I'm willing to pay for it? If it isn't, you're not going to buy it. If it is, if it has greater marginal benefit, let's say, or marginal utility, you buy it. If the price is higher than that, you won't buy it. So in this hypothetical example, N means the number of model airplanes you're expecting to purchase. And then these are just mythical units. I made these up, but these are to illustrate a concept. Obviously, if you don't buy any, you get no satisfaction out of that because you hadn't purchased any. If you buy one, that gives you 15 utils of additional satisfaction of total utility. If you buy the second one, that gives you an additional 16 utils of satisfaction. Why did I say 16? Because your total utility goes up by 31. So obviously the second one added 16 utils to your satisfaction. That would be your marginal utility. And so that's how you look at this. So notice that marginal is just the difference incrementally in the two values. And this is certainly true. You can just subtract the two values if these are in units of one. If they jump, say it goes from one plane to 10 planes, then you actually have to look at the difference in the total utility, the change in total utility divided by the change in the number of units. But here it's simple. We just look at the change from one row to another. Now, as you probably figured out, we're going to take that information and graph it. And notice here, total utility is increasing, but it's flattening out. We say that that is increasing at least over some range here. It's increasing, but at a decreasing rate. In other words, it's getting flatter. And then somewhere up close to this region here, around 12 or so, notice it flattens out. It's at the top. Now, just to make sure we're on the same plane, marginal utility is the change in total utility divided by the change in the number, in this case, of planes to be purchased. So here's the marginal utility based on that total utility schedule, that table of total utilities. Notice that marginal utility first increases, but then it decreases. It's not negative, but it's decreasing. So every additional plane up to some point in here, and actually it looks like it occurs somewhere in between 12 and 13. It's around 0 at that point. That'll be important later. Marginal utility is positive. In other words, it's positive values for the utils gain, but each additional plane that we expect to purchase, at least past this point, gives us less and less satisfaction. Well, that's an important concept in microeconomics, excuse me, and that's the idea of diminishing marginal utility. Now, diminishing marginal utility is critical. You understand that that doesn't mean that purchasing your second plane in this example is going to be less additional satisfaction than the first, but at some point that's going to happen. So eventually, the extra satisfaction of a good or service declines as consumers expect, it's before the fact, to consume more of that good or service in a particular time period. Again, DMU, diminishing marginal utility, does not mean that MU, marginal utility, is negative, only that it's diminishing. Now, let me throw in another thing. That's the same thing as saying the slope is negative. Now, if we didn't have to worry about the money we're going to spend on something, then we would want to maximize our total utility. And from the graph, you can see that total utility is maximized at the point where marginal utility is equal to 0. Let me go back a few slides here. And so we're talking about somewhere in between 12 and 13. And we're talking about in this range right in here. So you can see the total utility is at the highest point, somewhere between 12 and 13. So notice that we can get at maximization of total utility by looking at marginal utility where it's equal to 0. Now, if we have a budget constraint, what we want to do, and a lot of times students misinterpret what I'm about to say. Don't let your mind go where some of your minds will go. But when we're purchasing goods or services, we want the biggest bang for our buck. And what I mean by that is for every dollar we spend, we want the greatest increase in our utility. In other words, we want the highest amount of marginal utility. Turns out that with a budget constraint, in other words, when we have a limited amount we can spend on it, if we look at multiple goods, then the way we will maximize total utility is by setting the ratio of marginal utility per dollar spent. So this is one item, this is another item, this is another item. However many items we're talking about, as long as we stay within our budget constraint, then that's going to be our total utility be maximized when these are all equalized. That's called consumer equilibrium or the equal marginal principle. Different books call it a different thing. And let's understand why that's true. Okay, and let's just keep it simple down to two goods. So if we're talking about planes and boats, for example, if the additional satisfaction out of planes, let's let X be planes, per dollar spent, in other words, divided by the price, is greater than the additional satisfaction per dollar spent on boats, then for every additional dollar we spend, we're going to add to our total utility by more if we buy planes. On the other hand, if it's just reversed, we're going to add to our total utility, our satisfaction, more if we buy boats rather than planes. So we wouldn't stay at these points. We would buy more of one and less of the other, depending on which the ratio applies. So only at the point where they're equal, that says that every dollar spent on each good is the same, adds the same to total utility. And so at this point, we don't really care. There's a term called the rational consumer is indifferent. That will be important later. But the total utility is maximized where the ratio of the marginal utilities per dollar spent, that means MU over P, are all equal and the budget is exhausted. In other words, you have no more money to spend. So let's do an example, and this gets pretty tedious. And I'll be honest with you, my memory's not as good as it used to be, so I kind of forget too. So let's say we've got two goods, airplanes and boats. These are model ones. Airplanes cost $10, boats cost $20. And let's suppose we have $80 to spend on the two units. So here's a table of all that information. So this is the number of planes, the total utility of planes, the marginal utility of planes, the marginal utility of planes per dollar spent. In other words, MUP over PP. Number of boats, total utility of boats, marginal utility of boats, marginal utility of boats per dollar spent. So that's where all this data comes from. Okay. And so, as a rational consumer, now don't misunderstand what I'm saying. I'm not saying that each one of us do these calculations specifically in our head, but just intuitively, we're saying, okay, which one would give me more satisfaction? Which would I prefer to have relative to the price I'm going to have to pay? And so that's really what we're talking about. So, on round one, let's say we purchased no boats, no planes. And if we look at the marginal utility per dollar spent, well, for planes, that's 1.5. For boats, that's 1.7. So we would buy one boat, and they're $20. So we have spent $20, and our budget remaining was 80 before, so it's 60 now. And that first boat gave us 33 utils of total utility. So that's a marginal utility. It's only the first one, so it's both actually. So 33 utils. Now, the next round, we're not looking at the first boat. We've already purchased it. But the second boat and what marginal utility per dollar spent it will give us. And in this case, that second boat would give us 1.2 utils as opposed to the first plane, which is up here. So 1.5 is greater than 1.2, so we buy one plane. And then we go to looking at two planes and two boats. Okay, we've already bought one boat and one plane here. So the second plane gives us 1.6 utils per dollar spent. The second boat would be that 1.2, so we would buy a second boat, and then a third boat, and a fourth boat, and finally then, at this point, round six, they are equal, so we would be indifferent, and our total utility would be maximized, and we would have exhausted our budget. I know that's kind of hard to follow, but it's just the idea of looking at those ratios of marginal utilities per dollar spent and comparing the two, and whichever is the highest, that's the one we're going to purchase. Okay. Now, what happens if the price of model boats drops? Well, now in that case, the price has dropped to $10 for the boats. It was and remains $10 for the planes. That hasn't changed. But notice what happens to our calculations on how many boats and how many planes we're going to purchase. We purchase more boats. Well, that kind of makes sense, doesn't it? Because at a lower price, the marginal utility per dollar spent, that ratio is going to be higher with the denominator being lower for boats. And so notice how that changes. So notice that the quantity of boats that maximizes total utilities increases when the price of boats goes down. That's kind of like the law of demand, isn't it? So plotting the combination of various prices and corresponding quantities that come from utility maximization yields a negatively sloped line where P is the vertical axis, Q is the horizontal axis. Yes, that is the demand curve. So back when we were talking about the law of demand, and we talked about one of the reasons why the law of demand is true was diminishing marginal utility. Now you see why.